Imagine a computer so powerful it could crack every password on Earth in minutes, design revolutionary medicines in days instead of decades, and solve problems that would take today's best supercomputers millions of years. This isn't science fiction anymore. We're approaching what experts call the quantum tipping point, and it's arriving faster than most people realize. Right now, tech giants and governments are pouring over $40 billion into a technology race that could reshape everything from national security to how we discover new drugs. But here's what's fascinating. While everyone's been focused on AI, quantum computing has been quietly hitting milestone after milestone. Just last year, Google's quantum computer solved a problem 241 million times faster than the world's most powerful supercomputer. IBM went from 127 qubits to over 1,000 in just 2 years. And companies you use every day, from banks to pharmaceutical giants, are already running quantum experiments. So what exactly is this quantum tipping point? Think of it like the internet in the early 90s. Back then, the internet existed, but it was mostly for academics and researchers. The tipping point wasn't a single moment. It was when the technology became useful enough that businesses couldn't afford to ignore it. That's exactly where quantum computing is heading right now. Here's what makes quantum computers different. Your regular computer processes information in bits, ones and zeros. But quantum computers use qubits, which can be both 1 and 0 at the same time through something called superposition. It's like being able to walk through every path in a maze simultaneously, instead of trying them one by one. Add in quantum entanglement, where qubits can instantly affect each other regardless of distance, and you get computational power that grows exponentially. The race to build these machines is intense. IBM plans to have 100,000 qubits by 2033. Google's roadmap targets fault-tolerant quantum computers by the end of this decade. Even Microsoft, taking a completely different approach with something called topological qubits, claims they'll have a working system within years, not decades. What's remarkable is that all these different companies, using different technologies, are converging on the same timeline, 2029 to 2030, for the first truly useful quantum computers. But why should you care? Let me paint you a picture of what's coming. First, cybersecurity is about to get turned upside down. Every encrypted message, every secure transaction, every password-protected file uses math problems that regular computers can't solve quickly. Quantum computers laugh at these problems. Governments are so worried that they're already switching to quantum-proof encryption. China, the US, and other nations are in what some call a new arms race because the first country with a powerful quantum computer could theoretically read everyone else's secrets. But it's not all about breaking things. Quantum computers will revolutionize how we discover new medicines. Right now, simulating how molecules interact is incredibly difficult because the number of possibilities explodes exponentially. Quantum computers naturally handle these quantum interactions. Researchers have already used quantum computers to find promising compounds for undruggable cancer proteins. Imagine cutting drug discovery from 10 years to maybe just 1 or 2. Financial companies are particularly excited. JP Morgan, Goldman Sachs, and other banks are using quantum computers to optimize portfolios and calculate risk in ways that could save billions. Volkswagen used a quantum computer to optimize taxi routes in Beijing. Airlines could use them to solve incredibly complex scheduling problems. Even something as everyday as package delivery could become more efficient. Here's a mind-blowing fact. Some companies are already making money from quantum technology. Quantum random number generators, which create truly random numbers impossible for regular computers, are being sold for cybersecurity right now. It's a small market, but it proves quantum technology isn't just theoretical anymore. Of course, massive challenges remain. Qubits are incredibly fragile. They need to be kept at temperatures colder than deep space. The slightest vibration or electromagnetic interference can destroy their quantum state. Current quantum computers make errors roughly once every 1,000 operations, way too high for complex calculations. Scientists need to bundle hundreds or even thousands of physical qubits together just to create one reliable logical qubit. The skills gap is another huge problem. There are maybe 200,000 people worldwide who understand quantum computing well enough to work on it. Companies are desperately competing for talent, with senior quantum scientists earning up to $250,000 annually. Universities can't train people fast enough. So when will we hit the tipping point? The experts are split into three camps. The optimists, including Google's quantum chief, say we'll see real commercial applications within 5 years. They point to the exponential improvement in qubit counts and error rates. The quantum industry has its own Moore's law, and if it continues, we could have million qubits by 2030. The pessimists, including NVIDIA's CEO, think truly useful quantum computers are still 20 years away. They argue that unexpected physics problems always seem to pop up, and classical computers keep getting better too. Advanced AI might solve some problems we thought only quantum computers could handle. Most experts fall somewhere in the middle. They see the late 2020s as when we'll get the first clear quantum advantages for specific problems, with broader adoption through the 2030s. By 2040, quantum computing could be generating up to $850 billion in value globally. So what do you think? Are we really just years away from this quantum revolution, or is it still decades in the future? The truth is, the quantum tipping point won't be a single dramatic moment. It'll be a series of breakthroughs, each making quantum computers useful for new problems. We're already seeing the earliest signs with quantum cryptography and optimization. By 2030, expect quantum computers tackling drug discovery and material science. By 2035, they could be transforming entire industries. The companies and countries investing billions aren't doing it for fun. They see what's coming. The quantum revolution isn't some distant possibility. It's a transformation that's already beginning. And just like the internet changed everything in ways we couldn't imagine in 1990, quantum computing will reshape our world in ways we're only starting to understand. The race is on, the stakes are enormous, and the tipping point is closer than ever. The only question is, will you be ready when it arrives? Like and subscribe if you enjoyed the video.